Yeah, so hello everyone, I hope you all are doing well. So today let us discuss this topic, Java exception handling. So here in this video I'll be covering everything about this topic. There will be nothing else required and you will be able to answer all the interview questions related to this topic in your Java interviews. So it will be a bit long video because we all know that exception handling is containing a lot of parts into it, but just watch this video till the end and nothing else will be required. That is my promise to you. So let us first look into the contents we are going to cover into the different parts. So first of all, we will see what is exception and what is exception handling. We'll see a real life scenario where exceptions can occur and also how you can handle them. Also we'll go to the VS Code and we will see all these things. After this we have errors. We'll also see the hierarchy of exception classes in Java and exceptions versus errors, and after that checked versus unchecked exceptions. Also we'll see the practical implementation of keywords like try, catch and finally into our VS Code, and we'll also make our own custom exceptions, or we can say user defined exceptions, and we'll throw them by the help of throw keyword, and at last we will see the throws keyword. So as you can see, there is a lot of content we are going to cover and it will be complete for your interview requirements. Let us understand the exception and exception handling within real life example first of all. So here let us take an example of you and your friend going to watch a movie in a cinema hall. You are having a bike, let's say. You started your journey from your home and you will go till your cinema. Okay, so this will be a normal flow. Okay, but suppose in between, okay, if rain happens, then your flow will be disrupted, right? Your flow will be disrupted. But suppose you have tackled this issue by the help of a raincoat. Let's say you are having a raincoat. Now here there was a problem in your way, but you have tackled it by an alternate possibility. Okay, so this thing is known as exception, and this concept of handling that exception by an alternate way is known as exception handling. Okay, so this is one thing to understand. Now there is a possibility that your tire may got punctured. There is a possibility that let's say before entering into cinema hall a ID is required and you forgot that ID at your home. Okay, there is a possibility that you forgot ticket itself. Okay, so these things can be referred as exceptions in real life. So similar things will be happening in our programs as well. Now as all of you have seen what is exception and exception handling with a real life scenario, let us see the definition part of these topics. The exception is a unwanted event that will disrupt our normal flow, and exception handling is a mechanism to overcome that so that we can maintain our normal flow, okay, by the help of some keywords. Okay, we'll see all these things in the upcoming parts. Let me show you how the exceptions are occurring and how we can handle them. So here we are into our VS Code. Let us first begin with a basic example. Let's say I have a print statement, let's say start of the program, and let me have a result, let's say 100 divided by 2, and let me try to print it. And I have one more print statement, let's say rest of the code, let's say. So let me just compile it once and let me run it. So we are getting the output here, and let me make some changes into it now. Let's say divide by 0. So we know that we cannot divide an integer by 0, so this will throw an exception. Let me try to run it once. Okay, so here you see what is happening. First of all, start of the program is executing as it was supposed to be, and then here at line number 5 I am getting an exception. So the information about exception is given. So it is arithmetic exception, and some description about it is given, that it is divided by 0. Also the stack trace, or we can say the location of this exception is given, that it is occurring at line number 5. As there is exception in line number 5, so rest of the code will not get executed because of this exception. So it is the unexpected event, or we can say unwanted event, that happens in our program and that disrupts the normal flow. Now let me try to tackle this. So I'll just use try catch for now. If you are not understanding how this all is working, don't worry, in the upcoming parts we will understand all these things in detail. So for now, just let me keep it simple. Let me try to print it, and let me just format it once. Okay, so let me just run it again. Okay, so you see this time what is happening. First of all, start of the program, then here exception is occurring, but it is taking an alternate path. So it is printing the information about the exception object, and then rest of the code is also getting executed. So that is what is exception handling. So here we can understand that whenever there will be an exception, it will disrupt the normal flow, and we can use the mechanism of exception handling so that our program will be still running till the end. Also here we can see that exception is not removed permanently. Only thing is, whenever there is an exception, it is just taking the alternate path. If there is no exception, let me just put 2 here instead of 0. So you see it is taking the normal path as it was supposed to be. So this is the basic understanding of exception and exception handling. In the upcoming parts we will deep dive into it. We will understand how to handle the exceptions. Also we will understand how to throw our own exceptions. For now, let me just give you few more examples of exceptions. So earlier it was arithmetic exception. Let me try to bring one more exception, let's say null, and let me just try to take the length of null string. So if I run this again, there is one more exception is occurring. So this is null pointer exception. So some description about it is given. Let me give you some more examples. Let's say file input stream, let's say file, so new file input stream abc.txt as file name, and let us just try to run it for now. Again we can see one more exception is occurring, that is file not found exception. So this is a one more type of exception. Let us take one more example. Let's say str equals to Naruto, and let me take the integer out of this string. Let's say integer dot parse int of this particular str, and let me try to print I. So if I try to run this, I am getting an exception here, number format exception. For input string Naruto. So what is happening here? We all know that parse int is used to extract the integer part of the string. So here there is no any integer, so that's why it is throwing an exception. If it was integer, let's say 1 2 3, any number we can take. So this time it is not throwing an exception, it is running perfectly fine. So these were some examples of different exceptions we have seen, and we have also seen how we are tackling them by using try and catch. We will understand try and catch properly in the upcoming parts. For now, the basic understanding of exception and exception handling should be clear to you. So to summarize, as we have seen into our real life example as well, that an unwanted or unexpected event that is disrupting the normal flow is an exception. So same thing is happening into our program as well. We are having an exception that is disrupting the normal program flow, and exception handling is a mechanism to handle these exceptions so that we can maintain the normal flow of our programs. So yeah, now you have understood how a exception is occurring and how you can handle it into our program, and we can maintain the normal flow. Similar to this, we have errors as well in our programs. See, errors are bit different from exceptions. These cannot be handled, or we can say these are unrecoverable issues. These will be related to the system level. They will not be because of our coding, okay? They will be because of the system we are using. So there is a possibility of stack overflow, okay, out of memory conditions and virtual machine failure. So all these things are referred as errors. So let me just take you to this particular slide. There are a lot of type of exceptions which we can see here, and just now in VS Code we have already seen some of the examples of arithmetic and null pointer and number format as well, and also input output exception. So these were all exceptions which we were able to handle by the help of try catch or throws keyword. So there are these errors as well in our programs which are unrecoverable. So as we have understood till now that exceptions can be handled by a programmer and errors are unrecoverable issues. Okay, so yeah, let me repeat this again. So as you can see, these occurs at system level and these are unrecoverable in nature, and of course these cannot be handled by the programmers, and if there is an error, sure it will be leading to the termination of the program. But very rarely we'll see errors into our programs, because into our programs there is a possibility of occurring exception only. If it is a system problem, then that will be error. Now let us understand the next part of this topic, where we can see the hierarchy of exception classes in Java. All the exceptions and errors are having a parent class which is a throwable, and of course there is an object class which is the parent class of all the classes in Java. So here there are two different type of classes, one is error and one is exception. As we have already discussed the difference between errors and exceptions. Exceptions can be handled by the programmers, but errors cannot be handled by the programmers. Okay, so we will be focusing on exceptions only from now on. There are different type of exceptions that may occur. So here are some names for that: input output exception, class not found exceptions, SQL. Also there are runtime exceptions. So in exception itself they are categorized into two parts. One is checked exceptions and one is unchecked exceptions. So let me take you to the real life example again, and let me make this clear what is the difference between checked and unchecked exceptions. We have seen this example already, where you and your friend were going to cinema and there was a possibility, let's say rain happened, or maybe you forgot your ID. So two different kind of exceptions occurred. Okay, so here we will categorize both of them. Okay, so let us take the same example again and let us understand this. Okay, so here you see, before starting the journey itself, your friend reminded you to check the ID and check the ticket, let's say. Now if you check them, you can avoid the issue which you are going to get at this position, right, while executing the program. Okay, let's say till here your program is running, right? So this is your complete program. One part is riding till your cinema hall, and then having the authorization, and you get into the hall and you watch the movie, and let's say that is the end of the program. Okay, so here if you forget ID or ticket, of course there will be issues in your program flow. You will not be able to watch a movie, but you can check this possibility even before starting the journey. Okay, so this kind of thing is known as checked exceptions. Another possibility is, let's say in between the path or somewhere rain, or maybe your tire got punctured. So here this kind of exceptions are known as unchecked, which you cannot check even before starting the journey. Okay, even before starting the program. So that is the main difference between checked and unchecked. Okay, here we are taking a real life example. I will take you to VS Code now and I'll show you how you will see some exceptions will be detected by the compiler at the compile time, and some exceptions will be ignored by the compiler. So they will be considered as unchecked exceptions. So checked exceptions are also called as compile time exceptions, and unchecked exceptions are also known as runtime exceptions. Okay, but remember one thing, do not forget it, that all the exceptions will occur at runtime only. See here, you can only check your ID and ticket Okay, but if in case you do not handle this in the starting itself, the issue will occur during the program execution. In starting there will be no issue, right? You can start your journey, but in between somewhere your program will be terminated abnormally. The thing to understand here is both checked and unchecked exceptions will occur at runtime only, but you can check them either at compile time, or there may be a possibility that compiler can ignore them, so they will be unchecked exceptions. We have already seen examples of different kind of exceptions like arithmetic exception, null pointer exception, input output exception, and number format exception. So similar to this, there are many more exceptions which we have seen in the hierarchy of exception classes. So all these exceptions are categorized into two different parts. One is checked exceptions, one is unchecked exceptions. See, we have already understood this thing into that real life example of you and your friend going to a cinema hall on a bike, that all the exceptions are occurring at runtime only. Only thing is some exceptions are detected by the compiler even before compiling, so these will be under checked exceptions, and those which will be ignored by the compiler will come into runtime exceptions. So let us see these examples now. So I'll just remove everything from here, and let me just take a exception. Let's say result equals to 100 divided by 0, which will be a arithmetic exception, and let me just try to print it. So if I just go to terminal and try to compile it first, so let's say demo.java. So here we just saw that our program get compiled without any problem even if there was exception. So these kind of exceptions are categorized under runtime exceptions, which are ignored by the compilers. Now if I try to run this, of course it will throw an exception. Okay, now let us take a checked exception, which is input output exception. Let's say file input stream, file equals to new file input stream abc.txt. So here this is a input output exception which will throw an exception because there is no abc.txt here. But if I try to compile it first, let me just clear it. Now here we can see that our program is not getting compiled because of checked exceptions. Now there is this must thing that we have to do with checked exceptions, that if there is a checked exception into our program, we have to handle it or we have to declare it. Either I can put this code into try catch, or I can use throws keyword to declare it. So at least it will allow my program to get compiled this time. So here we can see it is successfully getting compiled. Now if I try to run this, it is throwing an exception. So that is the key difference between checked and unchecked exceptions. So if there is a checked exception, the compiler will not compile the program if it is not declared or handled by us. If there is an unchecked exception, it will ignore it at the compile time. So here we can see in this slide that these green colors are directly the subclasses of the exception class, are the checked exceptions, and there is one more subclass which is runtime exceptions, where all the runtime exceptions will be there. Okay, and errors are categorized into a different class. Now let us move forward and see the theoretical part of checked versus unchecked exceptions. So here, as we have already seen into our real life example as well as in VS Code, that checked exceptions are apart from the runtime exceptions, of course, here as you can see. Okay, so these all are checked exceptions apart from this runtime. Okay, and here for unchecked exceptions, all these which are under runtime exception class will be unchecked exceptions. So as we have already seen, the checked exceptions are checked at compile time, while the unchecked exceptions are ignored by the compiler. Okay, if there is a checked exception, of course we have to handle it in the starting itself, otherwise it will not allow our program to compile. Now let us see the most important part of this whole topic, which is try, catch, and finally blocks. Also we'll see the throw and throws after this. So I'll just remove everything from here, and let me just clear the terminal for now. So basically we use try and catch blocks to handle our exceptions. So what we do, we take the risky code into the try block and we handle the exceptions into our catch block. So this is the basic syntax I am pasting just for the understanding purpose. So we'll take the risky code into our try block and we will put the handling code into our catch block. We will understand these now. Let me just remove it, and let us again take the same example. So we have int result, which is 100 divided by 0, and I'm just printing result here. So we all know that this will throw an exception. Let me try to run it once. So let me just put /n and /n again here. Okay, so as we can see, it is throwing the exception. So what we will do here, we'll take this risky code, we'll remove it and put it into the try block. So here I will use the catch block to handle that exception. So we know that this is arithmetic exception. Let me give it name as, let's say, E. Any name we can give, and for now let me just try to print it simply. Let's see what we will get now. Okay, so this time our exception is handled and rest of the code is getting executed. Let us understand a bit more about it. So what is happening here? First of all, my starting of the program is running. Then at line number 8 I am getting an exception which is arithmetic exception, and the description is it is divided by 0. So what happens now, it jumps from line number 8 and comes into catch block directly, and then our exception is getting printed. Even if there is multiple statements, it doesn't matter. I am into try block. So if there is exception, it will directly go to catch block. So we are getting the same result. Now if there is no exception, then our try block will get executed and catch block is skipped this time. So that is the key takeaway for try and catch blocks, that we will take our risky code and put it into the try block, and then we'll put the handling code into the catch block. Now let us understand what is this arithmetic exception and what is this E. See, in the exception hierarchy we have already seen the different type of exceptions. So whatever the type of exception is occurring, we put the name of that exception class name here, and then we take a reference variable so that we can perform any operation according to our requirement. So here what happens, in most of the cases programmers know what kind of exceptions they are handling, so they usually put the name of exception. But if you do not know the name of particular exception for now, you can just take the parent class, which is the exception class, and the rest will work fine. Okay, let me make it an exception. Okay, so this time also we are getting the same output even if there is the parent class we are using. Okay, if I put, let's say, one more statement here, I am into catch block. So that is what is happening now. Whenever there is exception, our catch block is getting executed. If there is no exception, then our try block will get executed and skip the catch block. Also remember that we will keep the rest of the code out of try and catch. See, if I just take it here, you see what will happen. If there is exception, then of course the try block is getting skipped and the rest of the code is also not getting executed. So we should avoid putting the rest of the code into try and catch. We'll take only the risky code into the try block and handle that into our catch block. We can take other examples as well. Let's say I have string str equals to null, and the length of null is not allowed, so this will also throw an exception. Again, the starting of the program, again I am using the parent class, so JVM is automatically handling this, that what type of exception is occurring. So this time null pointer exception and the description about it, and then our I am into catch block line is getting executed, and after that rest of the code is getting executed. So in this way we can take the risky code into a try block to handle the exceptions. Let us also see the theory of try and catch. So as we have already seen into our VS code, that we will put the risky code into the try, and we will have the another block which is catch, which will be just after try, to catch that exception and create our alternative path. Okay, so this is a syntax which we have already used. Now let us understand this exception object as well. So you see, whenever a exception was occurring into our program, a exception object was created at that time. Now coming to exception object, let me just remove it for now. Let us again take the same example for our understanding. See what just happened here. Whenever there is an exception object will be created which will be carrying the information for that particular exception. So for this exception, the information given is the class name. So this is arithmetic exception, the description about it, that is divide by 0, and then the stack trace, which is the location of that exception, that it is occurring in line number 7. So this is the exception object which is created at the time of exceptions. Even if we handle this code, then also the exception object is created. So you see, this time also the exception object is getting created. So we have seen that the exception object is getting created, either we handle the code or we do not handle the code. If there is an exception occurring, then the exception object will be created. Okay, now as we have seen, every time an exception is occurring, actually there is an exception object which is created, which is carrying the information of that particular exception. So in that particular information, there will be three main things which will be covered. One is the class name, another is the description, and the stack trace, which is actually the location. Here we also have the different ways to print our exception object. One is by the help of e.print stack trace. In this, all these three informations will be printed from the exception object. Second one is by the help of SOP statement, which we have been using, and at last we also have e.getMessage. So in the second one, the location will be missing. In the third one, the name and location both will be missing. Okay, so you can use any of them. We have been using this SOPE is the one way. We can also use, let's say, e.print stack trace. So this time also the exception object is getting printed. So the difference between the two is, in the earlier one the stack trace is not getting printed, in this the stack trace is also getting printed. So let us just see the both. So in SOP statement, this stack trace is not getting printed, but in this stack trace will also get printed. Also we can use e.getMessage. So this will just print the description. So in this way we can print the exception object into three different ways. Now here comes the very important part, that how this thing is actually happening behind the scene. Whenever a exception was occurring, okay, so there is a possibility that either we will handle that exception or we will not handle that exception. So if we do not handle that exception, the JVM was handling that by the default exception handler, but that was resulting into the abnormal termination of the program. And if we handle that by the help of try, catch, finally, throw or throws by ourselves, then the program will take the alternate path. Okay, we will be able to handle that exception according to our requirement, and the program will be running successfully. So let us understand this by VS Code again. So I'll just remove the code and put int result equals to 100 divided by 0, and then let's say print result. We know that this will throw an arithmetic exception and we are not handling it. Let's see what is happening. So you see, first starting of the program is getting printed. After that the exception object is created and that information is getting printed. after that the rest of the code is not getting executed. So this happens when we do not handle the exception and when JVM handles it by itself. So what the JVM will do, it will create an exception object, it will print the exception object, and it will terminate the program there itself. It will not execute the rest of the code. Now if we want that our program does not stop in between, then in that case we have to handle the exceptions manually. We should not leave our exceptions to the JVM, otherwise it will stop the program in between. So let me just handle it. And this time the rest of the code is also getting executed. So now let us understand this finally block as well. So there is this interesting thing about finally block, that whatever you put into finally block will get executed every time, even if there is an exception occurring or not, even if we are handling that or not. In all the cases the finally block will be executed. So we use this for our important codes or for our cleanup codes. So this is the syntax which we can use. Either we can use it with try catch block or we can use just after try block. Let us understand all these things into our VS Code as well. So in this, as we just show in the slides, that it is used for cleanup code, or we can say important code, because it will get executed even if there is an exception or there is no exception. So let me just give you a demo for that. So let us just print I am into finally block. Let us run it. Okay, so in this I am into final block is getting executed if there is an exception. Now if I remove the exception, then starting of the program, then try block, and of course catch block is skipped, but still finally block is getting executed. Also we can use finally block just after try block. So let me just remove the catch block here and let us just run it. This time also we'll get the output, and if I just throw an exception here, then also this finally block is getting executed. And after that, as I am not handling the code by the catch block, our program is terminated abnormally in the between, and rest of the code is not getting executed this time. So if we want that rest of the code also get executed, then in that case we have to handle that exception which is thrown by the try block. So for that, let me just again put the previous code. So this time everything is working fine as expected. Let us understand one more interesting example about finally block. So I'll just take one method, let's say Naruto. So in this I'll just put try and I will return, let's say 2, then catch, then return 3, and then finally, and then let's say return 4. For better understanding, let me just take int result equals to 100 divided by 2 first of all, and then result. Okay, now let me just call the method into a print statement so that we can print the returned value as well. So theoretically it should print 50 because there is no exception, and then it should return 2 into the main method. But here you see the interesting result we are looking, that 50 is getting executed, but instead of returning 2, it is returning 4 from the finally block. And if there is exception, then instead of returning 3, again it is returning 4. So these are some interesting results of finally block. So we should use our finally block wisely into our programs. Usually we do not use finally block because try and catch are enough for handling our exceptions. But if there is some code which is need to be executed in any condition, if there is some cleanup code, you want to handle the memory leaks or you want to close the files, so in that case we can use the finally block. And at last we have this note that try block must be followed by either catch block or finally block, or both of them we can use. The second last part of our video is throw keyword and the custom exceptions. The throw keyword is used to throw the exceptions manually. See, if we want to throw an exception by ourselves, if we want to create our own exception and we want to throw it at particular part of the code, we can do that by the help of throw keyword. So we can throw the inbuilt exceptions as well as the custom exceptions according to our requirement at any line of the code, but usually it is used to throw the custom exceptions. So while throwing the exception, we can also send a message with it. Now let us understand how throw keyword is working. So basically throw keyword is used to throw the exceptions manually. So we can use this keyword to throw the exceptions at a particular point of code according to our requirements. So for example, I'll just throw the inbuilt exception first of all. So let me put that risky code into our try block. Let's say throw new, let's say arithmetic exception, and let us handle it. Let me just print I am into catch block, and let us also print the exception object. Let me run it. Now we can see start of the program is printed first of all. Then because of this throw keyword, a new exception is thrown, which is the arithmetic exception. So it is taking us to the catch block where I am into catch block is printed, and then the information about the arithmetic exception is printed, and at the end the rest of the code is getting executed. Now here we can notice that the description is not there. Also let us just take e.print stack trace and let me run it again. So this time stack trace and exception type is printed, but the description is not printed. So this throw keyword gives us the option to print our own exception messages. Let's say this is an manual exception. So this time the description is according to the message we have given into it. So we can use this throw keyword to throw the exceptions, but mainly it is not used for throwing the inbuilt exceptions. Mainly it is used to throw the custom exceptions, or we can say user defined exceptions. So to create the user defined exceptions, what we will do, we will make our own exception class. Any name you can give, let's say young age exception, which will extend the exception class. And here I'll just use the constructor for this class. I'll just send a string message here, and we can call the super constructor by using super keyword. So this will pass the message to the parent constructor, and let us just see how this is working. Let's say I have age, let's say 24, and then if my age is greater than equals to, let's say if my age is less than 18 years, then I can say throw new young age exception, and I'll just put my own message here. Sorry for that. Age is less than 18, so cannot vote. In else, I'll just put yes, you can vote. Let's see why this is giving an error. So this is giving me error because I am not handling this risky code, so I have to just take this and put it into try block, so that when the exception is thrown, it should be handled. I'll just print the information about the exception. Let me just use print stack trace for now. Okay, so let us just run this and see what we are getting. Okay, so first of all my age is 24, so I am coming into try block, and then here if block is not getting executed, and then else block is getting executed and there is no exception occurred, so this time yes you can vote is printed, and then catch block is skipped and rest of the code is executed at the end. Now if I just reduce the age, let's say 4 years, then here if block is getting executed and new exception is thrown, which we can say our own custom exception is thrown. So here young age exception is the name of exception, and this is the message, or we can say description we have given to our own exception by using the constructor. And at last the location of the exception is printed, which is nothing but line number 11. So at this line number 11 a new exception is getting thrown and rest of the code. So to create our own exceptions or to create user defined exceptions, what we will do, we'll just take one class, we'll give it a name, and then we will extend the exception class, and then we will use the constructor, and we can use the super keyword here to pass our message to the parent classes, and this throw keyword we are using to throw the exception on the required conditions. So in this way we can throw the exceptions and we can create our own exceptions. So the last part is throws keyword. So this throws keyword is used to declare the exceptions. Okay, so here it is actually not throwing the exceptions, it is only declaring them. So again I'll just remove everything, and let's see how throws keyword will work. So basically throws keyword is used to declare the exceptions. So this throws keyword is actually used for checked exceptions. As we already seen, checked exceptions are those exceptions which will not allow the program to get compiled if we do not handle them or we do not declare them. So either we can put the checked exceptions into the try catch block, or we can use the throws keyword to declare them. So basically throws keyword will not actually handle the exceptions, it will just declare the exceptions. Let me just give you example here. So let's say I have file input stream, let's say abc.txt, then I'll just use scanner sc equals to new scanner, and I'll just put file inside here. Okay, and let me just print sc dot next line. Okay, so this is the code I'm writing to read the data from abc.txt file. So first of all, as this is falling under the checked exception, it will not allow our program to get compiled. So let us see. So I'll just clear this once. So java c demo.java. Okay, so here we can see that unreported exception, either we have to handle it by the try catch block or we have to declare it by throws keyword. So either we can use try catch block. So in that case what we will do, we'll just take this code and put it into try block, and then I can handle it using the catch block, let's say. So let us just run it. So this is one way of doing this, but let us see the other way. So that is using the throws keyword. So in throws keyword, in the front of it we can give the particular type of exception, or if you do not know what type of exception this will throw, so we can use the parent class. Now here it is declared that this main method may throw an exception, it is not handling the code. Okay, let me just clear it once again. Let us compile it first of all. Let's say demo.java. So this time the program is getting compiled. Now if I run this, okay, so again what is happening now, the JVM is handling the code by itself, and we know what will happen when JVM will handle the code. We have already seen this in the previous parts, that it will disrupt the flow and it will not allow the rest of the code to get executed. So in that case I have to handle it using try catch. But then what will be the point of using the throws keyword? So we'll see now what is the main use of throws keyword. So let me just make a method, let's say static, let's say void, let's say Naruto again. Okay, so here I will declare that this method can throw exception, and I'll just take this part here, and let me just format document. So now what will happen, that here we have declared the exception, but still we have not handled it at any point. So if I run this again, the same thing will happen. The rest of the code will not get executed and it is stopping in between. So to handle that, I have to put this into try and catch. So now this will work fine. Okay, so if I just take e dot print stack trace, and let me just format document so that we can get the location of exception. So this time what is happening, the exception is occurring at line number 7 in Naruto method, because there is no file with abc.txt, and then it is telling that it is throwing that exception to the main method. That main method should handle it if it is not handled at this position, and in the main method it is handled, so that's why it is printing the exception information, and then rest of the code is getting executed. Now if I make the file, let's say abc.txt, let's say hello I am into abc file, and let us try to run it again. Okay, so this time starting of the program, hello I am into abc file, and then rest of the code is getting executed. Now what is the key takeaway from this example, that throws keyword is used to declare the exceptions. So how this is helping the programmers, that if I feel that my method may give some exception, so I'll just declare the exception. Now if some other programmer is working on the same file, then they can handle this declared exception at some other part of the code according to their requirement. So that is the main use of throws keyword, that it will actually pass the exceptions to the caller method, and then in the caller method we can handle that exception using try and catch. So we will put the method call into the risky code part, which is the try block, and then we will handle it using the catch block. So now we have studied all the Java exception handling from start till end. We have understood the real life examples. We have also understood the theoretical aspect of this topic. Also we have seen the practical implementation of all the subtopics. So we have understood that exceptions are the unwanted or unexpected events which are actually disrupting the normal flow of our programs. Exception handling is a mechanism which allows us to maintain the flow of program by using some alternate path. Also we have seen the errors, which are nothing but the problems with the system level which we cannot handle actually, and we will not see them usually. We will just see the exceptions. After that we have studied the hierarchy of exception classes, where we have seen the object class having the child class as throwable and having the two sub child classes which are errors and exceptions. Also we have seen in the exceptions there are two type of exceptions, one is checked and one is unchecked. So checked exceptions are those exceptions which will be detected by the compiler at the compile time itself. That's why they are also called as compile time exceptions. So they will not allow the program to get compiled. And the runtime exceptions, or we can say unchecked exceptions, are those exceptions which will be ignored by the compiler at the compile time. Also we have seen that all the exceptions will occur at runtime only. Only thing they can be checked at either compile time or runtime. Also we have seen the use of try, catch and finally block, where we take the risky code into the try block, and then the exception which is thrown into the try block is actually cached by the catch block, and we put the handling code into the catch block. Also we have seen the finally block, which is used to execute some important code, or we can say cleanup codes. After that we have studied throw keyword, and we have also studied how to make our own custom exceptions by inheriting the exception classes and using the constructor. And also we have seen how we can throw the exceptions by using the throw keyword at any line of the code according to our conditions. And at last we have seen the throws keyword, where we are declaring the exception so that any other programmer can handle that code according to their requirement at some other part of the program. I hope all of you have understood Java exception handling, and you will be able to answer all the interview questions related to this topic. Thank you for watching this video. if anyone is facing any doubts, you guys can put into the comment section. I will resolve them. And if you are studying Java or any other programming languages or development stuff, then I will be keep on uploading such videos, so you can subscribe this channel. Thanks again. Have a great time.